Welcome to This Explainer. Today, we're diving deep into the hidden infrastructure of our digital world. We are looking at how artificial intelligence is fundamentally rewriting the very fabric of image compression. If you think shrinking a file size is just some boring background process, well, get ready for a massive shift in perspective.
Let's start with a provocative question. What actually happens when AI decides what parts of a memory it's allowed to forget? That is our core focus today. Because shrinking a file, it's no longer just a math problem where we blindly squeeze bits together. It's transformed into an active, intelligent decision system about selective forgetting. The codec, the software actually shrinking the file, is now actively deciding what information gets thrown away and what stays.
Here's our roadmap for today. First, we'll hit the image compression ceiling, then dive into PICO and perceptual compression. Next, we'll tackle the generative control problem, introduce the energetic paradigm architecture, look at structuring perceptual governance, and wrap up with what AI may forget.
All right, part one, the image compression ceiling.
There's a really profound contrast right now between traditional tech and the AI era. Everyday technologies, we're talking your cloud storage, messaging apps, video pipelines, they all rely heavily on traditional codecs like JPEG or AV1. But honestly, we've hit a ceiling here. These older codecs are strictly rule-based. They optimize for something called PSNR, which is basically a formula that purely measures mathematical pixel similarity. But here's the catch. Human vision doesn't care about pixel math. Our eyes care about structure, edges, faces, and recognizable objects. A traditional codec might literally score a perfect 100 on a mathematical test, but completely ruin a readable street sign in the background. Learned perceptual codecs, on the other hand, like PICO, use generative AI to optimize for the actual human visual experience. It's a total game changer.
Moving on to section 2, PICO and perceptual compression.
So we're entering this wild era where JPEG AI is serving as an international standard, bringing neural networks directly into the formal compression stack. And PICO, which stands for Perceptual Image Codec, is where this engineering gets highly practical for everyday consumer devices. It solves three massive bottlenecks. First up, the one-shot context model. Traditional entropy coding, the final math step of packing the data, is incredibly slow because it processes step by step. PICO calculates the most important parameters in a single pass. That completely solves the speed problem for real-time mobile use. Second is text fidelity loss, which prevents the AI from hallucinating text. And third, tiling artifact loss. This stops images from looking like a weird patchwork quilt when they're processed in localized blocks, preserving the overall global coherence of the image.
I want to really emphasize that second point, text fidelity loss. When you use AI to compress an image, the AI often acts as a generator. It might look at a blurry, low-resolution patch of hair and just generate highly realistic new strands to make it look great to the human eye. And hey, that's visual beauty. But what happens if that exact same AI generates a plausible-looking but entirely fake letter on a medical document or a street sign? I mean, that is a dangerous factual failure. PICO handles this brilliantly by identifying text regions and forcing strict literal fidelity there, while still allowing more generative freedom in natural textures.
And to put that into perspective, this perfectly illustrates why all this complex engineering actually matters. To achieve the exact same perceptual quality, meaning how good it looks to us, PICO saves up to 70% of the file size. It requires only 30 to 43% of the bits compared to mainstream standards like AV1 or VVC. Imagine your phone's photo storage suddenly tripling in capacity without you lifting a finger, or cloud storage giants cutting their bandwidth costs by more than half. Achieving the exact same quality with less than half the bits, that could fundamentally rewrite the economics of the entire internet. Let's jump to section 3, the generative control problem.
Now let's pivot for a second from that massive technical victory to the broader risk. Our core thesis here is that perceptual compression is basically an early example of AI deciding what must be preserved. Think about it. Once a codec is generative, it's no longer just a passive compressor. It becomes a perceptual editor, operating quietly below the user interface. It is literally making decisions about what to preserve, what to distort, and what to hallucinate before you even know a decision has been made. The machine's objective and the human experience are no longer just linked by math, they are linked by active AI decision-making.
Which brings us to section 4, the energetic paradigm architecture.
So, how on earth do we govern a system that actively decides what to forget? Well, we use the energetic paradigm, or EP. Now, this isn't just a buzzword. It's a full reasoning architecture for perceptual information flow. It treats compression not merely as a file size problem, but as a governed transformation of information under constraints.
Think about the full chain: the source image, the encoded bit stream, the storage, and finally the downstream interpretation. EP is the framework that helps us distinguish between harmless loss, like throwing away invisible pixel math, and harmful distortion, like changing the letters on a prescription bottle.
Next is Section 5, Structuring Perceptual Governance.
EP beautifully generalizes this logic across entirely different constraints. Take a standard vacation photo. You want high generative freedom, right? If the AI makes the leaves on a tree look just a bit more vibrant, literally no one complains. But a street sign, that requires strict text fidelity. A medical scan requires absolute literal fidelity. An AI hallucinating a tumor or erasing one to save file space is catastrophic. An enterprise memory requires complete factual reliability. It becomes incredibly obvious that a vacation photo and a medical scan cannot possibly share the same compression policy. EP provides this exact missing governance layer for AI systems.
Finally, Section 6, what AI may forget.
We started with PICO as a concrete case study of how AI shrinks image files. But this overarching governance problem, it applies to everything: video, audio, documents, scientific figures, enterprise workflows, you name it. Every advanced AI system is essentially becoming a compression system that decides what to keep and what to discard. Ultimately, the next frontier is not just smaller images, it is reliable control over what intelligence systems are allowed to forget. I really hope this explainer has completely reshaped how you think about memory and the future of AI. Just think about that the next time you save a photo. Thanks for exploring this with me.